In this video, I'll be explaining you about laser, that is, light amplification through stimulated emission of radiation, or simply laser. Now we'll see the brief history of invention of laser. In 1916, Sir Albert Einstein gave the theoretical basis for the development of laser. He predicted the possibility of stimulated emission. In 1954, C.H. Stones put Einstein's prediction to partial realization. He developed maser, that is, microwave amplifier based on stimulated emission of radiation. In 1958, C.H. Stones and Arthur Shallow extended the principle of maser to optics, that is, lights. In the year 1960, T.H. Myman produced first laser device. Yes, it's T.H. Myman who invented laser. Now we'll see some basic principles of laser. They are absorption, spontaneous emission, pumping and population inversion, and stimulated emission. Let's see them one by one. Absorption. As we know that atom consists of different energy states. Let us assume two energy states, that is Eg as a ground state and Ex as an excited state. When a light photon of energy h nu, that is Ex minus Eg, hits an electron of a ground state, electron absorbs its energy and moves from lower energy level Eg to the higher energy level Ex. This is known as absorption. Spontaneous emission. Now we have already seen how the electrons move from a lower energy level to the higher energy level. These electrons do not stay in a higher energy level for a longer period of time. They fall back to the ground state by emitting the same amount of photon. So this process of electrons falling from the higher energy level to the lower energy level on their own is called spontaneous emission. This emission of photon happen in different phase and in different direction. Pumping and population inversion. Now let us consider an atom which has three electronic states, that is E1, E2 and E3. Generally, most of the electrons stay in the ground state, that is E1. As we have already studied in absorption, the electrons jump to the higher energy level, that is from E1 to E3. Now, due to the process of spontaneous emission, the electron does not stay in an excited state for a longer period of time. It stays for only 10 raised to minus 8 seconds. So, some electrons fall to the ground state by losing their energy, whereas some electron loses lesser energy and fall to E2 state. This less emitted energy is called as thermal energy, or this falling of electron from E3 to E2 state is called as non-radiative transition or invisible transition. Electrons stay in E2 state for a longer period of time as compared to E3 state. It stays for about 10 raised to minus 5 to 10 raised to minus 2 seconds. This electron state is called as metastable state. At some point of time, the number of electrons in metastable state will be more than the number of electrons in the ground state. This stage is called population inversion. So, how do we achieve population inversion? This can be done by the method called optical pumping, in which appropriate energy is supplied to raise more number of electrons to the higher energy state. Now we'll see stimulated emission. When an electron is already in an excited state and a photon hits this electron, the electron falls back from a higher energy level Ex to the lower energy level Eg by emitting two photons in a same phase and same direction. This is called stimulated emission. In the next video, I'll be explaining you about the working of laser, characteristics of laser, and some applications of laser. My name is Justina And I thank you for watching this video. Please click the thumbs up button and subscribe to my channel.